say example, those people who are doing research in stock market. Okay, so especially what year-end effect, weekend effect, days effect. I don't know whether there is a days effect or not. Okay, maybe the anomalies we always study. Okay, these are all the data in the nature of time series. Okay, every week we collect the data. Every month we collect the data. Every year we collect the data. So here in our example, GST collection of Tamil Nadu from 2017 to 12. Okay, GST collection of Tamil Nadu. I'm taking only one state, Tamil Nadu, from 2017 to 22. Okay, time series data. Then the second structure of data is cross-sectional data. Okay, here we are not using the time component, we are talking about cross sections, right? GST collection of the states. I'm here. The first category that I have given, it is Tamil Nadu alone. Right here, the collection of the states for the year 2024. So these states are, we call it as cross sections. Okay, so you say that the data collected over the sample unit, that sample unit can be an individual, can be a household or a firm, cities, states, or the countries, anything it can be. Okay, need not be the states alone. Even if we are studying about the countries effect. Okay, so countries effect. Okay, here we have how many? 1, 2, 3, 4, 5, 6, 7, 8 cross section units that we have.
So your PPT is not visible,
ma'am. Ma'am,
your PPT is not visible, sir.
okay, for others,
Sir, it is visible,
is it visible, right?
It's visible.
Okay.
It is visible, sir.
Yes,
it is visible, sir.
okay, ma'am. Thank you, ma'am. Thank you so much. Okay, so here you see that Kerala, first cross section, Tamil Nadu, Puducherry, Telangana, Andhra Pradesh, Himachal Pradesh, Punjab, Chandigarh. So each cross section. So totally 1, 2, 3, 4, 5, 6, 7, 8 cross sections we have. Okay, we are studying cross sections. Okay, this is another type of data structure. Then the third one is our intended topic, that's panel data. Panel data. So the basic name, so this is the very old name, we call it as that as a longitudinal data or cross-sectional time series data. Here it is cross-sectional time series data. So here we have both the components. We have the time series as well as the cross-sectional units. So this type of data structure, we call it as panel data. Okay? It is a data in which the behavior of all entities across time, all entities are observed across time. So where in certain cases you can able to understand the time effect alone, whereas in time series data. Whereas in cross-sectional unit, you can able to understand what are all the differences are there in the cross sections. Say example, when we are studying about 10 companies, what are all the factors that makes differences among the companies? That's what we can able to understand in cross-sectional units. But whereas in panel data, both the behavior could be understood. So the entities may be individual, firm, state, or countries, right? So I hope you understand what is panel data. Okay, so it is a combination of time series as well as cross sections. It's a time series as well as cross sectional data. Okay. So why do we go for panel data? No, the panel data allows you control for variables you can't observe or measure. Okay, it allows you to control. This is another perspective. So when you talk about in regression perspective, okay, we can observe all the factors that are impacting, or what are the factors that are making differences among the organization or differences among the time period. But our intention is not to find out the differences. Okay, we need to go for understanding the relationship between one variable to another variable, right? Okay. Say example, from my perspective, when there is a woman in board, maybe we call it as in a company board. Okay, there is a woman in company board. How does it affect the performance of the company? Okay, how does it affect the performance of the company? This is my intended meaning, intended what result. Okay, this is what I want to understand, or I want to measure. Okay, so the all other factors, then what are all the factors that can able to influence those factors could be observed and controlled. That could be observed and controlled in order to get the result of the women on board on the performance of the company. Okay? That can be possible in panel data analysis. Okay, so here it is given, you can't observe or measure, we call it as qualitative factor like cultural factors or the variable change over time, but not across entities. Okay, like pan-national policies, demonetizations. Okay, these are all that we can't measure. Okay, some of the things that, say example, national policies, we can't measure it. Okay, but that influence will be there in the regression equations. That influence, unobserved variables, we call it as unobserved. I think Rajesh Jar will talk about maybe what introduce the topic, latent variable. That's all. Okay, so those variables observed in panel data analysis. So that is the reason why we are going for panel data. Moreover, in Dr.
Sir,
Baltagi
I'm sorry
says,
to interrupt you. Sorry
yes,
to
ma'am.
interrupt you.
Yes, ma'am.
Can you please enlighten more on observed and unobserved data?
Ma'am, that we will discuss in the what model, ma'am. So don't worry. For say example,
Okay.
simply, I already told you, women on board has the influence on the performance of the company, right?
Yes, sir.
This is the indented result that we want.
Okay.
Okay, so you then there are some other factors like, okay, say example, what are all the factors may influence the
Salary,
performance of the company? Your profit. Your profit can also influence the company. Okay, then some other factors, profit,
yes, sir.
and all other factors, right? So that may
Yes, sir.
influence the regression equation. Okay,
Yes, sir.
if you put it in the equations, if it is measurable,
Yes,
unobserved, because we cannot measure it, right? Say example,
yes,
a policy of a company, how can you measure it? Only we need to run an equation only with the help of that it can be quantifiable, right? Quantifiable,
yes, sir.
any of the means. Okay,
Yes,
if
sir.
we are unable to quantify it, then how can we measure it? So those factors we call it as unobserved variable.
Okay, sir. Fine.
So
Thank
that
you,
variable should be controlled. I'm not going to measure it, but that variable can be controlled to get the effect of women on board on performance of the company.
Yes, sir. Now understood.
So yes, that can be done with the help of panel data analysis, right? That's the reason why we are going for panel data analysis. Then that here two, okay, sorry, one more two is there. Then 3. Okay, here there is one more two, so right. Okay, so this component has three firms: firm 1, firm 2, firm 3. And this year component talks about 35, 36, 37. Then 35, 36, 37. Again 35, 36, 37. Okay, So the year component, we say that as a time period, it is T. Then firm component, we talks about cross sections, C, or it can be called as number of firms, N. Okay, so the T talks about time period. So we have collected a data for 3 years. We have collected a data for 3 years, and there are 3 firms. So totally there are 9 observations. Okay, so for 9 panel data informations that we have, right? So so 3 time period and 3 cross sections. So this is time component, this is cross section component. Okay, so this is one of the example for panel data analysis. So here we are going to talk about the company specific factors and also the time specific factors. So both that we are going to measure it in the panel data analysis. So that's why we are going for panel data analysis. So the very basic thing is, when I experience it during my research work, so mostly uh, these analysis, panel data, time series, my friend also did that. I think she's also in the call. Um, and that's in time series. Very few people from commerce background are doing this research. And most of them, whenever I'm attending this panel data workshops, most of them are from management background and from what econometrics background and economics background. So it is more of complications, right? When we see that formula and all, that will be more complicated, very, very difficult to understand. So that's the reason that I thought it should be like, it is like running the software itself, that it's enough for me. That is what I think. Okay, so for commerce people, not more of econometrics, why that we need. So that it must be like what, running the software and getting the results to explain it, what it is. Okay, that's enough. We are not like an econometrician to do all this work, because most of the researchers and organizations, they always talk about what, why you're concentrating more on statistics. You just concentrate more on your theories, your subject matter. Our domain knowledge should be what, brought to out for publications and all. Why do we more talk about the statistics? That's my intention. So it should not be more of statistics and all. Okay, so little bit that we can understand. So no issue. So I think that it should be as light to this commerce fraternity. I hope that I'm clear about this. Then panel data. The panel data set is a set of Xi and Yi. Here I'm introducing two terms, Xi and Yi. You are all aware of it. X, we talks about independent variable. I think here it is independent variable, or we call it as exogenous variable. Independent variable or exogenous variable. The subscript IT talks about I is the cross-sectional unit. I is the cross-sectional unit. What is cross-sectional unit? Here it is, say example, it may be the firm or the states or any cross-sectional units. Then T, we talk about time series. So year 2004, 2005, so to any number of years. Okay, so XIT is the independent variable X for the company. Say example for the company 1 for a period 2004 from our data, right? So maybe for the firm, for the first firm and for the year 2004. Way that it works. So XIT and YIT. Because panel data, when you run a regression, that the regressions will be what? For the whole years. So 10 years for the company, the regression equations will be for the first company, for the second company, for the third company. So it run a regressions like that for every year. Okay, for every companies. Okay, so that's why it should be put it in this way. So independent variable for the first company for the first time period, and dependent variable Y for the first company for the first time period. Some of the benefits of panel data analysis. Okay. The panel data analysis help in controlling individual unobserved heterogeneity. Then panel data gives more informative data, more variability, less collinearity among variable, more degrees of freedom, and more efficiency. Then panel data analysis can be better detected and measure effect that section or time series data. Dedicated behavioral model, then purely cross-section or time series data that can't. Then panel data analysis provides an opportunity to use larger data set and provides larger degrees of freedom. Okay, so these are all the basic benefits that I will put forth. This is the model of panel data analysis. So now we are entering into the topic. So will be like this. Okay, so YIT is the dependent variable. Beta naught, we call it as this as an intercept term. Intercept term. Okay, intercept term is nothing but what? An average value of whatever the value that you have. Okay, it is an average in the intercept term, and the remaining components are the, we call it as XIT is the independent variable, and that independent variable coefficient is beta 1 IT. So in our term, we call it as that as a slope. We call it as that as an error term. Okay, we already discussed about unobserved variables. So where there is any unobserved variable, so it is purely based on the data that you have. Okay, you just collect 4 or 5 data and do a run a regression. Okay, but that 4 alone, if we are what unaware of it, or we are not we what unable to measure it, or there is an unobserved variable, that variable will be captured in the error term. We call it as this as an error term. Okay, this unobserved effect will be what in the error term. Right? Say example, if your model fits 90%, then remaining 10% will be analysis. The error term, it should not be there in panel data.
Repeat error term, and sir, whatever you are writing with this red color, it is not visible.
Okay, okay, ma'am.
So kindly
I will
change
type.
the
So
color
it
of
is,
this. Either
ma'am, I think.
white is more visible. White
Okay.
or black you can.
Yeah, ma'am. I will try.
And kindly repeat this error term once again.
Yes.
And sir, we can say that intercept is the value of the dependent variable when we put all the independent variables 0. Can we say like this?
Ma'am, sorry, I didn't get.
Sir, I want to say another way of telling what is intercept. Intercept is beta 0 IT, right?
Yes, beta IT.
Yes. So we can say that the intercept we can define in a way that the value, it is the value of a dependent variable when all the independent variables are zero.
Yes, exactly. You can say that.
So can we say like this also?
Yes, ma'am. Yes, ma'am. Yes, you can. There is no data for that particular period. Okay. That's why I said I can use it or not. But if we don't have a data for the particular year, say example, so I'm collecting data for company one, company two, company three. Okay. So this is the way that it goes. So for a company, I have a data for 34. So 1935, 1936. Okay. So for company 2, I have the data for 4 years, 1934, 1935, 1936, 1936. For the third company, I'm having data for only 2 years. For example, third company, for the third company, I have data for 1935 and for the 2 years, 1936. Okay. So maybe when we talk about the dividend perspective, when we are talking about dividend perspective, some of the companies may not declare dividend, okay, for all the years. Okay. Some of the companies may not able to provide dividend for all the years. There are different policies, right, in dividend. So they are unable to provide dividend on the particular year. So what will do? We have taken 10 companies, right? So 10 companies, we usually what depend upon this premier institute, right? When we collect the data for a secondary from the secondary sources, the reputed journals won't accept the data which is collected from money control, right, or any of the ordinary websites. They will look for Thomson Reuters, Prowess IQ. That the ordinary arts colleges, we are unable to collect the data. Even when we go to collect the data, they won't allow us. Many of the organizations, they won't do it, right? They simply neglect to accept our, right? So during this time, we have to depend on this secondary data, and whatever that the Prowess IQ or Thomson Reuters or any other or what the say example World Bank data or the RBI data. So when there is a data, it will be available. If there is no data, it will not be available. Okay. If we want to study, which is very important, then what we can to do? Okay, even though there is no data, we have to collect the data and do the analysis. So any of the cross section data, say example, for a companies, I have only 3 years data. For company 2, I have 4 year data. For third company, I have only 2 year data. Okay, what can we do? Can we refuse to do the research? We can't do it. So this type of data, we call it as unbalanced panel data. It is unbalanced. There will not be an equal number of values. Okay. So example, if we are taking 5 companies, 10 years, for all companies, there should be 50 data. Okay. But so some of the this shortcomings, we may not able to get this 50 data. So that type of data, we call it as unbalanced panel data. Okay, unbalanced panel data. If we have 5 companies over 10 years, 50 data, all the data that we have, if that is the case, that is we call it as balanced panel data. Okay, so only based on this data that analysis may differ. Okay, so here we are going to mostly discuss about balanced panel data, right? So even our VHD, our what guide won't allow you to get unbalanced panel data. Okay, we need to collect data for 10 years, means 10 years that we have to collect it, right? Our researchers won't allow, supervisor, right? So we always mostly discuss about balanced panel data. Okay, so here the unbalanced panel data, the analysis mostly to choose what type of data that it will be helpful, right? So otherwise that it won't help. So you need not worry about it. So for understanding, there are two type of panel data. One is balanced. If we have an observation for all the companies, unbalanced panel if we miss any of the data or we are unable to collect from a particular website. Okay, so that we call it as unbalanced panel data, right? So this is the two methods, balanced and unbalanced. And we switch over to the estimation models. Till now, I think I'm clear. So if you have any doubt, kindly ask me. So it is more of theory. So if you want to ask anything, kindly, please.
I, sir, told you to explain error term, please.
Yes, ma'am.
Error term.
Error term we will discuss in the model, ma'am.
Okay.
It's okay.
Okay, no problem.
So, no problem. But error term is nothing but we should have enough information. Say example, now the students are going for a school, right? They already started going schools, right? So if we run a model, that what are all the factors which is affecting the test score of the students, right? So when we run a model, test score of the students, right? So what are all the factors which affect your method of teaching? Maybe I take method of teaching, right? So method of teaching or any other factor, funding levels, then teacher input,
Infrastructure.
Ma'am, infrastructure, yeah, very good. Infrastructure. Okay. Then we put it error term. Okay. So these are all the factors. In panel data model, one benefit is there. Okay. If we can able to observe the factors, we can use dummy variable, right? I think many of the people who did in time series also. So we can introduce dummy variable. Okay. So that we will discuss. So I just put it, these are all the factors. So test score is the dependent variable. It depends on the method of teaching, funding levels received by the college, okay, the input given by the teacher, and the infrastructure facility available in the particular school. Okay, these are all the factors. Is it enough to measure the test score, or is there any of the factors can influence?
Students
Yes,
interest
there
also.
could be more also.
Yeah, the parent teachers, the parents input.
Students
right?
interest also come.
Student interest can influence. The aptitude of the students can influence.
Students' feedback.
Yeah, feedback in the sense, ma'am. Student feedback in the sense.
Feedback about the teacher or about the college.
No. We are talking about test score.
Okay.
Okay,
Students'
exam.
regularity,
Yeah.
attendance.
Yeah, regularity and attendance. Yeah. So these are all the variable you can able to identify. If these variables are measurable, we can include in the equation itself. We will include that in the equation itself, right? So it may be a 10 variable or 20 variable. We will include it in the regression equations. But we don't know those factors. We don't know the factors. So if we don't know the factors, then those influences will be what in the error term, right? Am I right?
Yes, sir.
You said the parents'
Yes.
effect is there. That parents' effect, we didn't put it in this equation. We are unable to put it because it is unobserved. We don't know whether it can impact or not, right? We should have an information about that. We don't have an information, so that we don't know. So that will be captured in the error term. So if these variable, these 4 variable can able to define the test score up to 70%. So there is a 70% dependence of these variable on the test score. Okay, then the remaining 30% will be all other variable that will be captured in the error term. This is the basic regression model. Your error term will be in these factors. Okay, so error term. So if you can able to identify those factors, then that could be introduced in the regression equation itself. We are unable to introduce it. That's why that will be captured in the error term. Right, ma'am? Can you got my point?
Yes, sir.
Okay. So I hope I'm clear in this perspective, right? Then we move on to panel data estimation models, right? So we have 3 models, panel data estimation models. The number 1 is pooled OLS model, pooled ordinary least square model. Pooled ordinary least square. You know that OLS already. So ordinary least square technique. So pooled in the sense we put together all the observations. We put it like that. So when you are doing AMOS, you put it together, all the variables from first observation to 100th observation, all the 100 observations. So put it in the equations that will run and give you a data for all the variable. For the 100 observations, right? You can't measure it for a single person, any one person. You can measure it. You put it together. Okay. So in that sense, this panel data estimation model, like especially pooled OLS model, will accept all the variable and run an ordinary least square. Okay, so pooling of data means all the observations, we call it as all the observation of the data set are pooled, ignoring the individual and the time heterogeneity. Okay, time heterogeneity means the differences. Heterogeneity in the sense the differences. So we ignore, the basic assumption is we ignore the individual effect. We ignore the time effect. We assume that there is no individual effect, there is no time effect. Okay. Say example, we are studying 10 companies. Okay. Maybe we call it as the performance of the company. The company data, we are measuring the performance of the companies for 10 companies. Each company is specific in based on different perspective, based on the capital that they are investing, the people that they have in the management, the organizational structure, okay, the area of their existence, Tamil Nadu or state of Andhra Pradesh or Maharashtra or Gujarat, right? When we talk about during the Modi government, the people of Gujarat is doing extremely good. Maybe I'm not open up that perspective, but the thing is that there will be some sort of nepotism will be there, right? Nepotism. I don't think. But there is an individual heterogeneity. There will be some individual differences. Okay. Time heterogeneity. Time effect will be there. Every year there will be a differences. Okay. So maybe sometimes 3 years and the remaining 7 years will be differences. There will be differences. During pandemic, that everything was drastically vanished, right? So that type of differences are there. Time effect is there. But while running this pooled OLS, pooled regression, we assume that there is no individual effect, there is no time effect. That means, in the perspective of company, all the companies are the same. In the perspective of time, all the years, whatever that they are doing, are the same. Okay. That is not the good assumption, but if the data is like that, then we go for a pooled OLS. Pooled OLS. I just given you that the parameters beta naught, beta 1, beta 2, beta KIT. So all the parameters will be constant if it is safe. If it is same, that all the parameters will be constant. So, and in that case, we run a pooled OLS. So, we are doing basic analysis, right? In AMOS, these are all the example for pooled regression. We pool all the data and do a regression. Then we go for a fixed effect model. Okay, fixed effect model. If it explores the relationship between predictor and outcome variable within an entity that are time varying. With a time varying. Then, while using the model, we assume that something within individual entity unobserved time invariant. So here that I'm introducing another term called time invariant. Time invariant. It means based on the time, it won't change. It remain constant. Okay, based on the time, it won't change, remain constant, and may impact the predictor or outcome variable, and we need to control for that. So in that sense, we use fixed effect model. Okay, so it is time invariant. Generally, in Gretel, we need not worry about it. The time invariant factors will be automatically removed from Gretel. Okay, automatically removed. Say example, in my research, I have used one of the variable called age of the company. Age of the company. Age of the company means from its inception. From its inception, how many years of existence it has in India. Okay, so that variable, when we do an analysis, say example, for example, I'm collecting a data for 1935 to 10 years, right? So every year for the company, first company will be the same, right? 25, 25, 25, 25, 25, 25, 25 years of existence. It is time invariant. We call it as it is time invariant. Okay, it remains constant for all the years. So that type of variable will automatically removed in the regression equation. But there will be differences in what? Individual. There will be differences in company perspective. So first year, first company may be 25 years of existence. The next company may be 35 years of existence. Right? So the first 25 is for the first company remain constant. Right? So that time invariant factors will be removed automatically. Okay, then unobserved time invariant. Sometimes there is an unobserved time invariant that will be captured with the help of dummy variable. That's why this fixed effect model is otherwise called as least square dummy variable model, right? That we will do it in the a Gretel. Okay, so we call it as this as a fixed effect model, and the third one is random effect model, right? So a random effect model as like fixed effect model, right? But the values, say example, if fixed effect model, we know that variables and all, we know exactly. But random effect model, it is of larger population, we select some companies From the larger population, we select some companies. That company should be representative of the particular companies, right? So then there will be a concept of variance. So random effect model always talk about variance. It is, we call it as random error. Okay? That error term will be random. Okay, so it account for variability or differences among organizations. In REM, the common intercept represents the mean value of all the cross-sectional intercepts, and the error term represents random deviation of individual intercepts from this mean value. So the error term is not directly observable, it is known as unobservable. It is known as unobservable. Okay, so this is for the basic understanding. You need not worry about it. Okay, the thing is, we have three type of analysis. First one is we have to run a pooled OLS regression. Then second one is fixed effect model. Then third one is random effect model. So we have three models. We have three models. So among this three model, we have one more test. We call it as Houseman test. We call it as Houseman test. Houseman test. This Houseman test is for choosing which model is the best model among fixed effect model and random effect model. This is helpful for choosing which is the fixed effect model and random effect model. So this is what basically that we need to understand. So we have three models: pooled data, fixed effect, random effect. So out of these three models, Houseman test is run to identify which model is best among this three model. So this is what we need to understand from this section. Okay. So about this assumptions, we will discuss later. So basically in time series data, we first run this assumptions first, right? We first run assumptions, then we move on to the model. But in panel data, from my understanding, that most of the researchers who suggested that we need not do the assumptions first. We can first go for the model. After choosing the model, we can go for these assumptions. That is the paper, many of the paper that it would suggest. So that's why we will move on to assumptions at the later stage. So I hope that I'm a little bit clear. And please be ready with your Gretel software. We will do the hands-on session now. Is it okay? Shall we move on to hands-on session?
Yes, sir.
I hope everybody is open with your Gretel software. So kindly open the Gretel software. So shall we proceed further, or I have to wait for some time? I hope everybody have installed, and also you are having that Grenfell data with you, right? I'm sorry, I thought that it would take roughly 30 minutes. I think I took 1 hour, I think so. Am I right? Shall I proceed? Doing analysis in the Gretel is very, very simple. So moreover, Gretel is the open source software. So you can do your analysis without paying anything. You need not depend on this crack version and all, because it's open software, you can use it. And also, I think for the panel data analysis, that it will be more fruitful. That will give you consistent results. Shall I proceed? Or I have to wait for some more time? Can you please put it in the chat? Shall I proceed it? Yes,
So you can
yes.
proceed.
Yes, sir,
Thank you, ma'am.
proceed, ma'am.
Yes, ma'am. Thank you, ma'am. Thank you so much. So this is the Gretel software I'm having. So this is the front page of this Gretel, right? I think you have this Grenfell data. Even if it is not, no problem. So you just go to after this page. I hope that I'm visible my laptop. This go to this file, open data, right? Go to file, open data. Here we have two options. One is user file, another one is sample file. Okay. User file means our data. So I have stored my data in my laptop or desktop. Okay. If you are depending on the sample file, there are number of sample files are there. So Gretel, Greene, and Ramanathan. Okay, there are three set of data available already. Used data are available. So these are all the data were used by the econometricians like Damodar Gujarati, Oldridge, Baltahi, right, and Greene, William Greene. Right? These are all the people who have used those data, right? So the Arlano bond model is there. Okay, so many of the data is there. So we can use those data from here itself. Okay, you can select any of the panel data here itself. So I'm not going to select from that. I just go to file, open data from user file. You just click user file. From the user file, here give all files. Give all files because we are going to select it from our laptop. So give all files here. Okay, all files. So maybe where you are having your data, just click it. So I have my file in SRM workshop. So I have chosen SRM file and Grenfell data. Should I repeat it or is it okay? Right, I'm repeating.
Sir, shall we write the steps or you are going to provide anything for these steps?
Where, ma'am, I have to say or what? I have to write it in.
No,
Or you
I'm
are
not.
going to write.
I am only watching you
Okay,
because
okay, ma'am.
both to do simultaneously not possible for me.
Okay, ma'am.
So that's why I'm asking, shall I write all the steps?
Okay, ma'am, please. So here, from file, open data.
Yes.
Okay.
Then
So user file.
file.
So I have a data here itself, but I just go to user file. So this dialog box will appear. So from this dialog box, add last. Above this open button, you give all files, right? Then you choose, because we will have only Excel file, right? So that's why I'm choosing all files, or you can choose Excel file itself. Okay. So I just go to my desktop, because where that I'm having my file, right? So go to desktop, SRM workshop. So I just select Greenfield. Yes. So that this dialog box appear. So column 1 and row 1. So I'm going to give the data from the column 1 to row 1 itself. So this is the place that I want to paste. So you keep as it is, whatever that it comes. So click OK. Now all the variables come to that page, and also there is a small dialog box. The imported data have been interpreted as undated. Do you want to give the data a time series or panel interpretation? Because we need to give this interpretation because it is a panel data. So click yes. Right. So click yes. So here there are three components: cross section, time series, and panel. We are using panel data. So click panel, forward. Right. So some of the researcher mostly suggest that if your variable is of balanced, you can click any of this stacked time series or stacked cross sections. But if it is unbalanced, you can use index variable. But most of the workshop, they always use index variable. So here I just click stacked time series. Okay. So if it is a balance, you just click stacked time series. If it is unbalanced, use index variable. Okay. It is stacked time series. I click so forward. Here we need to specify number of cross-sectional unit we have. Okay. Number of cross-sectional unit that we have. So usually we should specify that. So for that, I just close it. I just click the firms. So firm data, I have firm 1 for 20 years. You just see that I just click the variable. Okay, I just come out of that page and just click the variable firm to see how many cross sections are there or how many time period is there. So the first is time period. So 1 to 20. So there are 20 years data is there. 20 years data. Then firms 11111 means first firm. 2222 means second firm. So like that, we have 10 years data. Sorry, 10 firms data. So 10, 10, 10. So we have 10 firms. So firms mean cross section, years mean time. So we have 10 cross sections and 20 time period data. Okay. So I just go to Gretel again. Sorry. File, open data. I just used Greenfield data. Once you have used that, it will come to this recent files. So you can choose from this itself. So I just start import from, then give time series or panel interpretation. Yes, it is a panel data. So forward. So it's a stacked time series because I have a complete data. You know that 20 years data, 10 firms. Okay, it is a balanced panel data. So I just click stacked time series, forward. Here that I need to put number of cross-sectional unit. How many cross-sectional unit is there? How
10.
many cross-sectional units? It is 10. So we have 10 cross-sectional unit. So you need not do anything. After choosing 10, it automatically come, the number of time period is 20. So totally 10 into 20 observations we have. So you put it forward, our data is time period, based on the time period. Okay, so every year that we have a data. So when you click the year data, when I check the form, no, likewise you just click the year data, that it will show you from which year to which year it is ending. So I am having annual data forward. So the year from that we need to specify. If you use index variable, you need not give this. If you use index variable, you need not give. For stacked time series, you need to give. Here I'm having data from 1935. So put it forward. So panel data, stacked time series, 10 cross-sectional unit observed over 20 period. The time dimension annual 1935 to 54. Okay. Okay. So this is what you need to give first. Right? So this is the basic step to import your Excel file into panel data. Right? So that whether I need to redo it or is it okay? I hope that it's okay, right? We just move on to analysis. Right?
Yes, sir. Continue, sir.
Yes, ma'am. One minute. Sorry. Right. Okay. So this is that we have already imported this files, Excel file into Gretel. So the Gretel software, it shows you the first is constant. The constant we need not calculate. So automatically when you upload the data, that it will take the constant, right? There is a constant. Okay. The form constant means the intercept term. Okay. We used in the regression equation, right? Intercept term. That will be automatically calculated. So 0, constant, firm, year, invest, value, capital stock. Okay. So firm and year are the panel components, and invest, value, and capital stock are the our variables. In this model, we say that the dependent variable is invest. Dependent variable is invest. That invest is depending on the value of the stock, sorry, the value of the company and the capital stock that they are having. Okay. So the investment, maybe we call it as the amount of investment, how much that the company has to make. It is depending on the value of the firm, what the total assets has, and the capital stock that they are having. So based on that, the company will make an investment. This is our regression model. So here, invest is the dependent variable, and value and capital stock are the independent variable. Sorry, here that I can unable to use this pen. So that's why I just choosing. Okay. First and foremost, I said panel data analysis, we have to do three things, three type of analysis. One is old OLS, second one is fixed effect, third one is random effect. Okay, this is the three models. Okay, so first one, we need to check the poolability, whether the data can be poolable or not. Okay, we have to check whether the data can be poolable or not. So for that, we need to run an ordinary regression equation. Okay, so we need to check whether the data is poolable or not, because this is the basic assumption. All the companies are the same, all the time period are the same. So this is the basic assumption. So we need to check the poolability. whether the data can be poolable or not. Okay, so for that, so do follow me. So here we just go to model, right? Then come to panel data. Okay, just go to model, panel, fixed or random effect, right? We did that by way of clicking the model, right? First click the model, go to panel data, then choose fixed or random effect, right? So this is the dialog box. Here we are going to specify which is dependent, which is independent. Okay, so permit here that we are not going to talk about here. Here we are going to talk about which is the independent variable and which is the dependent variable. I already said that invest is the dependent variable. Okay, you just select invest and click the arrow button. Okay, so in the dependent variable box there are two boxes. The first one is dependent variable, another one is regressor. Okay, so independent variable we call it as regressor and dependent variable we call it as regressand. So there are different terminologies that we use. Okay. So click invest and click the arrow, that automatically comes to dependent variable. That is the easiest way that you are doing in AMOS itself. Then choose value under capital stock by clicking shift. Click this green color button because we need to put it in the regressor box. So value and the capital stock are the independent variable. So put it in the so constant already is there. You need not select because automatically that it comes, right? Okay, fix or okay. Then already it is there in the fixed effect and random effect. There is no pooled OLS, so need not worry about it. We need not select any pooled OLS or all. So here it is enough. So keep it as it is. It is clicked as fixed effect. Keep it as it is. Don't do anything. Just click OK. Just click OK. You will get this result. Just click OK. You will get this result. I hope you got the results. Okay. I hope you all get this result. Is it okay? I have to do it once again.
Yes, sir, please.
Ma'am, sorry. Shall I proceed it or I have to do
Yes,
once
sir.
again?
Yes, sir, you can, sir. Yes, sir.
Yeah,
Once
again.
again, sir.
Oh, once again, right. So here you need not worry about it. I just click invest because I can keep it that cursor anywhere else. So that's why it is selected. So you need to select. That's not important. You just go to the model, go to panel and fixed or random effect. Fixed or random effect. So click invest is my dependent variable. In our study, invest is the dependent variable. So enter that in the dependent variable box here. It is like a blue color, I think, blue or gray color. So you put it here, invest in the dependent variable. Click set as default because we are always going to use invest as a dependent variable. So I click set as default. Then select value and capital stock. By clicking shift, I'm selecting value and stock. I just click that green arrow to put it in the regressor box, right? So I have given dependent variable and regressor. So I need not select anything because already it is in the fixed effect. Keep it as it is. So click OK. You will get this model. equation, fixed effect using 200 observation. You need not worry about it. We are going to check the poolability. We are not running the pooled OLS. We are not running. Kindly understand. We are not running pooled OLS. We are running whether this data are poolable or not. Or the data is poolable or not. That is our intention. Okay. So I have chosen this. So from this, we need not going to interpret any of this, right? Maybe for writing a paper, you can present it. I have done poolability test also. So this is the result that I am presenting. You can present it. But for other things, you need not present anything from this table. So you just go for this test for differencing group intercept. The test for differing group intercept. Differing group intercept. The group intercept is differing or not? Okay, that is what our intention. Okay, so here the null hypothesis says the group have a common intercept. The group have a common intercept. It means the data is poolable. The group have a common intercept means the data is poolable. Okay, we assume that all the people are same, one and the same. They are not different. So the data is poolable. So the group have common intercept is otherwise called as the group. The data is poolable. Okay, so you just go to this p-value 8.70015e minus 45. Okay, so from the superscript it is minus 45. It means what? The value is closer to 0. It is closer to 0. Right, 8.70015 e power minus 45 means the value is closer to 0. So if the p-value is closer to 0, otherwise called as less than 0.05, the p-value is less than 0.05, right? 95% confidence interval, okay, confidence level. So 5%, right? So your p-value is less than 0.05. What will you do? If it is less than 0.05, we reject. No, ma'am. We reject the null. Okay. So I think in what AMOS that you always talk about research hypothesis. This is the very old concept. It is like in Grittel we have null hypothesis and alternative hypothesis, whereas in AMOS and all you always use a research hypothesis, right? Okay, here it is null hypothesis. The group have common intercept. The data is poolable. Okay, your p-value is less than 0.05, so we reject the null. We reject the null. It means it is not poolable. It is not poolable. There is a differences, right? Have you got it? I hope you got my point.
Yes, sir.
Yes. So the null hypothesis, the group have a common intercept, is otherwise called as the data is poolable. That's a null hypothesis. So here your p-value says it is less than 0.05. So we reject the null. Okay. So the conclusion is that data is not poolable. There is a differences. So that is the result that we are coming out of this table. Right? Have you got my point?
Yes, sir.
Okay. Then, okay, so that we know that the data is not poolable. There is a differences. What difference are there? Whether it is an individual effect or a time effect. Yeah, that we don't know. whether it is an individual effect or a time effect, any of the factors. Okay, so you need to check that right from this model. Okay, you already have this model, the result. Okay, you just go to test. So from the model itself, you just go to test. Okay, what we are going to learn here, it is the data is not pullable. The reason will be individual effect or a time effect. Okay, it is based on the time effect or the individual effect. The data is not pullable. Okay, what is the reason? Whether it is the time, the reason, or the what individuality in the organization is the effect. So to test that from the result page. Okay, so we have already received this result, right? So from the result page, we just go to test, right? Click cross-sectional dependence. It means cross-sectional dependence. Cross-sectional dependence means that the company, in the company, is there any difference? In the companies, it is based on the company or it is based on the type. Okay, for that we go for cross-sectional dependence. That cross-sectional dependence says have to be interpreted based on Pesaran CD test for cross-sectional dependence. Okay, that it says Pesaran CD test for cross-sectional dependence. Okay, you just write it here. The null hypothesis is there is no individual effect. Here you just write it. The null hypothesis is there is no individual effect. There is no individual effect. So you just go to the p-value. It is 3.14 e power 0.06. Whenever you have an e power something, it is closer to 0. Right? E power something means closer to 0. Our null hypothesis is there is no individual effect. There is no individual effect. So your p-value is less than 0.05. So we reject the null. We reject the null. Our null hypothesis is there is no individual effect. Our p-value less than 0.05. So we reject the null. So therefore, there is individual effect. There is individual effect. Right? Is it okay? Dear participants?
Yes, sir.
Is it okay, right? So there is a individual effect. Okay. So I just close it. You can use these values. So first test for difference in group intercept, and second one is Pesaran CD test. These two tests can be used to prove this. Okay, whether it has individual effect or not, whether this data is pullable or not. Okay, that you can use it. If you are writing a paper for good journals, you have to present it, right? So you can use these value to present it. Okay, then we have identified there is a individual effect. We have identified there is an individual effect. Then we move on to time effect. Whether there is a time effect or not. Whether there is a time effect or not. To check that time effect, we just go to model once again. Again, model. Go to panel. Then go to fixed or random effect. So we now our intention is what? To check the time effect. So far we did individual effect. Okay. Then we move on to time effect. Right. So nothing but based on the time whether it is varying or not. Right. These are all have to be observed. Right. Then we are going for what? Identifying time effect, where there is a time effect or not. So model, panel, fixed or random effect. Okay, the same dialog box already we have given a dependent variable and there is independent variable too. So with this, we can include one more thing, that is include time dummies. Now let me say that we don't know that there is a time effect or not, and whether we may have the enough data or not, that maybe there will be some sort of unobserved heterogeneity, time heterogeneity, unobserved time heterogeneity. Anything may happen in a particular, right? 10 year we are collecting data, 1 year anything may happen. Maybe like in a family ownership, right? When the father dies, okay, there will be some sort of problem in the family itself. That may happen in a particular year, right? You are collecting data for 10 years. In any one of the years that it may happen, that year there will be a difference, right? Okay, there will be differences. We may not know. Okay, so to find it, that time differences, you have to go for, so that may be observable or unobservable. If it is unobservable, we may not know. We cannot able to introduce into the regression equation. So under this section, we include dummies to observe that heterogeneity. We include dummies to observe that heterogeneity. Okay, you know that the what dummies will be given particular example. Say example 1 year 95. When we assume that 95 will be taken as a base, means 95 will be given and all other years will be given 0. Right? If this issue happens any maybe, right? Okay, so in that way we include dummies. Okay, so just click include time dummies, then any other thing, nothing you have to do. You just click include time dummies and fixed effect already is there, it is. Okay, so just click OK. Just click OK. Just click OK. So this is the result. This is the result for me. Okay, so from the result, you see that the dummies we have given. So dummies 1 to 20 I have given. 1 is taken as a base. Usually, and while running in equations, when you are going for introducing dummy, if it is there are 20 years, you have to give only 19 years, because exact collinearity will be there, because first year will be taken as a base, right? So that first year everything will be 1. For the second year there will be a differences. Which year that you are taking as a base will be 1 and the remaining will be the 0. Okay, so 1 will be automatically removed in a panel regression. That grittle will remove it. So it is to avoid dummy variable trap. Maybe econometrician wouldn't know about this. Okay, so from this result we need not check anything, any significance or not, because we are going to learn is there any time effect or not. That's our intention. Okay, we are not going to interpret any of the data here. We just move on to this wall join test on time dummies. Wall join test on time dummies. That is the last category. Wall join test on time dummies. You just see that the null hypothesis is no time effect. The null hypothesis is no time effect. There is no time effect. Okay, you just go to the p-value. It is 0.112786. You just see it is above the p-value or less than the p-value. If it is 5%,
Above the p-value.
Above the p-value, right? It
Yeah,
is
that's
above 0.05. So we fails to reject the null.
Right.
Fails to reject the Null. So there is no time effect in this model. Right? So we just run the pullability. Pullability, we have seen the data is not pullable. So we move on to why it is not pullable, whether it is because of individual effect or a time effect. For individual effect, we depend on what? Testing differences or okay. So for the individual effect, we found that there is an individual effect, right? There is an individual effect. Here we run to test the time effect. We depend on wall joint test on time dummies. So from this result, we come to know that there is no time effect. Okay, there is only an individual effect is there. So that's why we are unable to run the fold regression. We are unable to run the fold regression. If we unable to run the fold regression, then we move on to fixed effect or random effect model. We just move on to fixed effect or random effect model. Is it okay? Right?
Yes.
Is it okay, dear participants?
Yes, sir.
Sir, Enoch, sir.
Yes,
Then what should I do? Shall I proceed?
Yes, sir.
Up to what time, sir?
How much time it will take, sir?
Sir?
How much time it will take, sir?
Sir, that it takes too much. because we are in this first stage itself.
Okay, sir.
There are number of analysis is there.
Okay,
Okay.
sir.
So I will try to do until 7:45, right?
Okay, sir.
Is it okay?
Okay, sir.
Okay. So
Okay,
so
proceed,
please, sorry for this
Okay,
because we have more lot to discuss, sir. So in
Okay.
panel data analysis, it's that we need to take it too much. Even that assumptions itself needs 1 or 2 days. Okay.
Okay, sir.
So we are not going in the perspective of econometrician. That's why we are making it as simple as possible. So I shall take up to 7:45, right? Then it is what joint test on time dummies. So we found that there is a differences. Okay. So sometimes if you found while you are running a fold regression, you found that there is no individual effect, no time effect. Okay. So we found that there is an effect, whether time or individual effect is there. If there is no individual or time effect, we can run the pooled regression. Okay. So if we want to run a pooled OLS, okay, if we want to run a pooled OLS, okay, just go to the model. Okay, I hope you following. We found that there is an individual or time effect. That's why the data is not pullable. Okay. So after examining all those things, we think that there is no individual effect, there is no time effect. It means what? We can pull the data. Okay. If the data is pullable, then we just simply depend on OLS. Okay. Just to run a pooled OLS regression. How to do a pooled OLS regression? Okay. I just go to model, just do an ordinary least square, to run a pooled regression, right? I just go to model, go to ordinary least square, you select invest in the dependent variable, and value and capital stock are independent variable. We need not click any dummies and all. Okay, here we don't need dummies because dummies we introduced to observe the time effect. Okay, here we need not enter dummy variables. So click Okay, don't include anything, don't click anything, just click OK. This is for running pooled OLS. Okay, if the data don't have individual or time effect. The data no individual or time effect, we just run a pooled OLS. For that, we just go to model, ordinary least square, select the dependent variable and independent variable in the regressor box. Don't click anything, just click OK. So this is the pooled OLS model. This is the pooled OLS model. So from the data set, we already know that there is an effect of time and individual. So these are all the data results will be inconsistent. I'm sure about it, right? So need not worry about it. This significance value that it shows some errant results. You don't worry about it. It's errant results. So when you receive any model, what are all the factors to be looked into? Okay. First things, these three. So more specifically, these two independent variable, whether it is significant or not. Okay, that's the usual way. I think the 6 days that you have learned a lot about it. Okay, so here the value and capital stock, whether is it significant or not. So 1% significance level, we have a 3 star. So at 1% significance level or 0.00001, whatever it may be, significance level, both are significant. Okay, so you can see that the dependent variable is invest and all other basic data here. Okay. Then you have to go for R square value. That's the usual R square value and adjusted R square value. We always say that R square value and adjusted R square value should be related. So here 81 means it is somewhat related to 81. Why that we insist on this? If any of the irrelevant variable you include in the regression equation, when you include any of the irrelevant variable, right, that variable may not affect, okay, or maybe there will be an spurious what correlations or whatever it may be, regression. Okay, so if you include any of the irrelevant variable, your adjusted R square will diminish. Your adjusted R square will be diminished. So that is the reason we should depend on this R square and adjusted R square in the pooled OLS. Because while running Grittle, that in each model the values will be different. LSDV R square, some sort of differences is there. When we go for that, we will discuss. So R square and adjusted R square should be relevant, or what? It should be parallel. Parallel in the sense related. So 81 more or less related with 81 or 80. Okay, there should not be gradual decrease in the adjusted R square. If there is a gradual decrease, then you included some of the irrelevant variable in the regression. So you have to identify it and remove it. Then only you can have a consistent result. Okay. Then one of the most important thing is Durbin-Watson statistics, right? Durbin-Watson statistics. That Durbin-Watson statistics will tell about whether there is an autocorrelation issue or not. Okay. Autocorrelation issue or not. Okay. So you know that most of the researchers have a different benchmark rates. Somebody says that if there is less than 1, right, we call it as positive, and more than 4, more than 2, 3 negative autocorrelations. If it is between 1 to 3, there is no autocorrelation issue. Okay. Or somebody that your Durbin-Watson statistics, most specifically your Durbin-Watson statistics should be closer to 2 if there is no autocorrelation. should be closer to 2. That is the benchmark rate. Okay. Somebody would accept that it is between 1 to 3. Some of the researcher will accept. Okay. So if it is 1 to 3, it is okay. If it is more closer to 2, it is better suited model. There is no autocorrelation issue in that model. So these 3 have to be reported, especially the significant level, R square and adjusted R square, and Durbin-Watson statistics. Somebody will explain this p value for the significance of this model, overall fit of the model. Okay, so that is also done. Okay, so this is the way you have to report this model, pooled OLS model. Okay,
Sir,
if you have any
can
doubt,
you repeat how we check for autocorrelation?
ma'am, please.
How we check for autocorrelation? What does
Ma'am,
it
this
mean?
Durbin-Watson statistics, ma'am. Durbin-Watson statistics should be close to 2. Close to 2. Or in between 1 to 3, ma'am.
Okay.
In
That
between
is
1
the
to
range.
3. If it is 1 to 3, there is no autocorrelation issue in the data.
Okay.
Or maybe we call it as from in our perspective in the error term. Okay. So this Durbin-Watson statistics is not like, then there is a problem of autocorrelation. From our data, there is a problem of autocorrelation. Because we already seen that there are some issue. Individual at a time effect is there. So there will be issue. That's the reason why we are not going for this pooled regression. So I just tell you just for how to interpret the results. Right. Okay. So far that we have discussed checking of poolability and how to do pooled OLS. This is what we did. Okay. Right. Then what shall I do? Shall I proceed further?
Sure, if time permits.
Okay. Okay, ma'am. Then just move on to fixed effect model. Right. So the same way that we can go for fixed effect model. So I just tell you how to proceed it. Right. So just the same way, click model, go to panel, click fixed effect model. Okay. You put it dependent variable as invest and independent as value and stock. Okay. Then click OK. So this is normally running this fixed effect model. So this is the fixed effect model results. Okay. So while discussing all those values, these are all what significant. Here you just see LSTV R square model. LSTV R square model. Okay. So where we have already discussed about R square and adjusted R square. Here we have to depend on this LSDV R square model and within R square model. Okay. But there is a gradual decrease here. So 944073 and 76758. Okay. And also that there is a problem of Durbin-Watson statistics. Here Durbin-Watson statistics also is not consistent. Okay, but this model is also not suitable. Okay, this is also not suitable. So we cannot run a fixed effect model too. Yeah, can you got it? It's a very simple analysis. The same analysis we already discussed. Model, panel, fixed or random effect. You just click dependent variable, independent variable as it is. Click fixed effect and give OK. Right. This is the normal fixed effect model. Okay. So generally, the fixed effect model, otherwise called as LSDV, LSDV model. LSDV model in the sense least square dummy variable model. Okay. So I already told you that it is time invariant. Fixed effect model would observe time invariant factors, right? And there is a constant factors in what we call it as that individual. Okay. So that in order to observe the unobserved heterogeneity, we include dummies. Okay, we call it as the dummies of each cross sections. So we apply dummies of each cross sections. So in order to create that dummies, okay, I'm talking about fixed effect model, LSDV model. Okay, to observe this heterogeneity, unobserved heterogeneity, we run a LSDV model. So that LSDV model take the dummies of individual entities. So in order to give or create that individual dummies, we just go to add unit dummies. Add unit dummies. Unit dummies means for each cross sections it will provide dummies. Okay. Each cross sections it provide dummies in order to observe the unobserved heterogeneity. Unobserved heterogeneity. Right. So after creating, how to create? You just add unit dummies. Unit dummies. Here it is time dummies also. Time dummies, it is based on the time. 20 years means 19 time data dummies will be created. Here unit dummy means we have 10 companies. For 10 companies, 10 minus 1 dummies will be created. So 9 dummies will be created. So unit dummies, just click unit dummies, you will have a DU1. DU means dummy for the unit. DT means unit for time. The time that we have given in the pooled OLS while running the time effect. Okay. So after creating this DU1, right, you just go to model. So there is a difference. Could you please understand? First, I run fixed effect directly. Okay, I'm not here going to create fixed effect. Instead, I just go to model ordinary least square. Okay, so I'm going for LSDV model. So ordinary least square, select invest and dependent variable, that is this constant value and capital stock. Then one more thing, your unit dummies. All the unit dummies you need to put it. Okay, all the unit dummies, right? I put all the unit dummies in the model. Okay, right. So you need not click anything. Here it is include time dummies. Dummies already clicked, used. So you need not worry about it. So I have given all the unit dummies. Okay, to observe unobserved what? Individual heterogeneity. So put it okay. So this is the what? LSDV model result. This is the LSDV model. The one variable, just here you see one variable omitted due to exact collinearity, because for 10 companies, the data will not give 10 dummies because there will be a exact collinearity. That is the reason why it remove one. That one will be taken as a base. Okay, so based on this 10 other 10th company, we interpret the data. Okay, how these dummies, these companies differ from 10th company. That is the way it will be interpreted. Okay, so D10 is automatically removed. This is the LSDV model result. So you can use this LSDV model. So this is the LSDV model is the usually used fixed effect model used. Okay, there are different methods like within estimator, okay, first difference model and all. So mostly we use LSDV model. So this is the LSDV model result. Okay, here also there are some problems. So still our Durbin-Watson statistics is 0.68 only. Okay, R square and adjusted R square 94, even sometimes 94 at a high correlation. So right, from my perspective, that we can say Watson statistics still say that there is an autocorrelation issue, right? So that's problem. So error term should not be autocorrelated. So again, there is a problem. For this data, we cannot run even LSDV model 2. Okay, then we move on to right. We move on to random effect model. We move on to random effect model. So the same way we go to model, panel or fixed effect model, click invest as the dependent variable and all other dependent variable as independent variable. Here I'm not doing anything regarding dummies. Okay, I just click only dependent variable value and capital stock. Instead of fixed effect, I'm clicking random effect. Instead of fixed effect, I'm clicking random effect. The Swami Arora will be the same. You keep it as it is. Swami Arora is the mostly used model. Okay, so don't worry about it. You just always use Swami Arora model. So click OK. Right. So this is your random effect model. This is your random effect model. You need not worry about it. This random effect model. Here still there is a problem of Durbin-Watson statistics. So even this model is also inconsistent. It means what? We have to take a lag of it. Lag of dependent variable. If we take a lag of dependent variable, this model become dynamic panel data model. It becomes dynamic panel data model. Okay, so from these models, we come to know that these three models are not suitable because your Durbin-Watson statistics still there is a problem. Okay, so just for understanding, I just explained you this random effect model. After coming to this random effect model, you just go to the last test, Harsman test. I already told you, no, there are three models. You can run pooled OLS, random effect, fixed effect. Okay, from this model, which model to choose? That will be given by the Harsman test. Given by the Harsman test, right? So you just take this Harsman test. Null hypothesis is GLS estimates are consistent. You just see that null hypothesis, GLS estimates are consistent. It means random effect model is suitable. I'm repeating, null hypothesis, GLS estimate, generalized least square technique. The generalized least square technique is nothing but REM model, REM, REM model. So the REM model is suitable from our interpretation. Okay, REM is suitable. You look at the p-value, it is more than 0.05. Okay, so more than 0.05. So what is the observation? So the conclusion is
We failed to reject null.
null. It fails to reject the null. So GLS estimates are consistent. So the REM model is suitable. So from this understanding, out of this three model, pooled LSDV FEM model and REM model, that REM is suitable. So you can use this as the final, REM model as the final, then you can interpret this REM model. With the help of REM model, you can go for the assumptions. Okay, so here from this understanding, this REM is suitable. But here even our REM is also with some problem. Darwin-Watson statistics is misleading. Okay, so in order to avoid this issue, then we can use that dependent variable as an independent variable. Okay, so I just click model, the final panel, I'll fix a random effect. Okay, then I have clicked all those values and I click random effect is the best model. So I just choose random effect, click lag, click lag, click lag. I just tell you one thing. So there is a problem. I already told that there is a problem because Darwin-Watson statistics still 0 point something. So there is a problem. Okay. So to avoid that problem, we can use that model as a dynamic panel model. It is another area we need to discuss, but we don't have a time. So I just tell you how to do it. Just simply, you just give dependent variable and regressor. Our model is random effect model. Choose random effect model because your Hausman test says that random effect model is fitted model. And click lag. The left hand side, there is a lag. Click lag. So in not give anything, click lag of dependent variable. Click lag of dependent variable. Here one means first difference, first lag. Okay, so click lag of dependent variable. So click OK. Right, you just see that inverse dependent variable, lag of inverse is a regressor. Lag of dependent variable is a regressor. We included the lag of inverse, that is lag of dependent variable, into the regression model. If you use that lag of variable, dependent variable in your model, that model is called as dynamic panel model. That model is called as dynamic panel model. Okay, so you just click OK. Now look at the Darwin-Watson statistics. Now look at the Darwin-Watson statistics 1.28. Okay, so that Darwin-Watson statistics 1.28, so I already told you that if it is between 1 to 3, you can choose that model as a best model. So from this random effect model, our Darwin-Watson statistics also consistent. So, and all other variables are also significant. Okay, but we don't have adjusted R square and R square because this REM model depend on variance. It always taken into consideration variance. Okay, so here you just see the correlation. Okay, just see the correlations. So based on this correlation, you can say that your model 95% fit. 95% fit. Okay, so from this you can conclude that your random effect model is significant. Your correlation says 95%. So your model is fit and it is explaining 95% of variance of dependent variable on independent variable on dependent variable. Right? Have we got it?
Yes, sir.
I think that I have given you some sort of information regarding panel data. So I hope that at least that you can able to understand the basic procedures of running this data. There are some of the assumptions are there, then that we need more time. Even these are all the informations we learned from more than 5 days or 10 days workshops, right? so that we need more. Okay, so with this, I complete. If you have any questions, you can please ask me. Sorry for taking too much of time. And also, whether I hope that I have reached you somewhat. So, from my perspective, even if I have given a little bit of information as a take home, that is my success. So thank you so much for all the administrators from SRM Institute of Science and Technology, the head of the department, Chitra ma'am, and especially all the coordinators and conveners, more especially Dr. Enoch sir for introducing me to SRM University and to all my friends. And also I thank my friends all from Bishop Weaver and also my friend Kokila from Christ, from Crescent University. So, and all my friends, thank you so much for your patient listening and all. If you have any questions, please ask me. Otherwise, sir, over to you.
Sir, thank you very much, sir. You have explained, you said it is very difficult. But you
Yes.
have explained this in a very lucid manner.
Thank you, ma'am. Thank you, ma'am. Thank you so much, ma'am.
Your way of teaching is very good.
Thank you, ma'am. Thank you. Thank you for your credit. Thank you, ma'am. Thank you so much, ma'am.
Thank you so much, sir.
Sir, thank you, sir. Thank you so much, sir.
Thank you, sir.
Ma'am, please.
Okay, as we come to the conclusion of today's enlightening workshop on introducing to panel data analysis, it's my honor and pleasure to extend a heartfelt vote of thanks. And I would like to express our deepest gratitude to our distinguished guest, Dr. Balamurali Krishnan. A special thank you to all the participants for your active engagement and enthusiastic participation, and your insightful questions, thoughtful discussions, and collaborative spirit have greatly contributed to the success of this workshop. And I once again thank you, sir, for coming and giving the valuable insights, sir.
Thank you, ma'am. Thank you so
sir.
much, ma'am. Thank you, ma'am. Thank you so much.
Sir.
Thank you. Thank you, all dear friends, dear participants. Thank you so much.
Sir, kindly share your number or email.
Sure, ma'am. I just put it in the chat. Okay, ma'am. I just put it in the chat. Kindly use. If you have any doubt, kindly send a small message. I just call anytime. Thank you. Thank you so much. Thank you for this opportunity. Especially.
Thank you, sir.
Thank you,
ma'am.
sir.
Thank you. Thank you. Enoch, sir, thank you.
Thank you. Welcome, sir.
Thank you, sir.
Thank you,
Sir,
sir.
shall I leave?
Yes, sir.
Yes, sir. Thank you.
Yes, sir. Thank you, sir.
Thank you, sir. Thank you.
Sir, shall I end the meeting?
Yes, sir. Yes, ma'am.
Yes, ma'am. Yes.
Okay, ma'am.
तो फिर बताना चाहिए। ये तो उनको बताना।